The youth center has installed a swimming pool on level ground. The pool is a right circular cylinder with a diameter of 24 feet and a height of 6 feet. A diagram of the pool and its entry ladder is shown below. To the nearest cubic foot, what is the volume of water that will be in the pool when it is filled with water to a depth of 5 feet? The volume of a cylinder is given by this formula pi r squared h, where r is the radius and h is the height. So volume of a cylinder is pi r squared h. We're going to take pi as 3.14, but there's also a pi button on your calculator. Using this 3.14 and the pi button on your calculator will give two slightly different answers, so be careful of that. The radius here is 12. The diameter is all the way across the circle. That's 24. Radius would be half of the diameter, or half of 24, which is 12. The height that we're filling this to is 5. I'm sure one of those answers down there is using a height of 6. We're not using a height of 6. We're using a height of 5 in the question. So volume is pi r squared h. I'm going to use pi as 3.14. That's going to be a little bit off of using the pi button on your calculator. So 3.14 times the radius squared would be 3.14 times 12 squared, and then times the height we're filling this to, which is 5. Order of operations, do the exponent first. 12 squared is 144. So take 3.14 times 144 times 5. It's going to be 2,260.8. That answer is not showing up, even to the nearest cubic foot. This would be 2,261. So what's the difference? Because I rounded pi. That's going to be a little bit off than if you use that pi button. That pi is stored in your calculator. So that's going to be a little bit different. It's probably going to be this 2,262. But the closest answer to this 2,260.8 is 2,262, so we're going to go with letter C. Same setup, different question. A plastic cover is made for the pool. The cover will rest on top of the pool and will include a wedge-shaped flap that forms a 45-degree angle at the center of the cover as shown in the figure below. A zipper will go along one side of the wedge-shaped flap and around the arc. Which of the following is closest to the length in feet of the zipper? So here's what we're going to do. We're going to find the circumference of the entire circle. Then we're going to use that circumference with that 45-degree angle to find this arc length right here. So the circumference of the circle is pi times diameter. Some people think of that as 2 pi r because 2 times the radius is the diameter. I'm going to use 3.14 as pi, and the diameter is given to us here. It's 24. So pi times diameter would be 3.14 times 24. Now that is rounded because I'm rounding pi, so that is an approximate answer, 75.36 for the circumference. That's a distance all the way around the circle. Now I need to use this 45-degree angle to figure out this arc length. What I mean by using that 45-degree angle is 45 degrees is 1/8 of a circle. A circle is 360 degrees. So 45 over 360, 45 degrees is 1/8 of the entire circle. So I need to find 1/8 of this 75.36, or divide that 75.36 by 8. That will give me that arc length right there. So the arc length is 9.42. And then also I have part of the zipper here as the radius. That's the easy one. The arc length is hard to get, that part of the zipper, but the radius is easy because it's pretty much already given to you. The radius is half of 24. The radius is 12. Add that onto the 9.42, and you get 21.42. It says which of the following is closest to the length in feet of the zipper? Well, the closest one to 21.42 is 22. Answer G is correct. Now here's something funny. Don't do it this way. If you count up those notches, if you can see that, if you count up those notches or those hash marks, there are 22 hash marks. Some people do it that way. Don't do it that way. Answer G. Same setup with the swimming pool, different question. 2 hoses are used to fill the pool. Twice as many gallons of water per minute flow through one of the hoses as through the other. Both hoses had been on for 12 hours and had filled the pool to the 4-foot mark when the hose with the faster flow stopped working. The hose with the slower flow then finished filling the pool to the 5-foot mark. Which of the following graphs shows the relationship between the time spent filling the pool and the height of the water in the pool? So both hoses had been on for 12 hours and filled the pool to the 4-foot mark when the hose with the faster flow stopped working. So you're looking for which graph looks like that is taking place. So which of the following graph shows the relationship between the time spent filling the pool and the height of the water in the pool? Well, this appears that you have a sharp takeoff in filling with water. This appears that you have a sharp decline in the filling with water. Water is being let out of the pool. This is a steady flow, so that's not the case here. You have, again, water being let out of the pool. And then you have this one. So a steady increase in water filling the pool, and then the increase slows down or tapers off a little bit, but it's still increasing. So that would be the one where both hoses had been on for 12 hours and then filled the pool to the 4-foot mark when the hose at the faster flow stopped working. That's the case here. Letter E. Same swimming pool setup, different question. The directions for assembling the pool state that the ladder should be placed at an angle of 75 degrees relative to the level ground. Which of the following expressions involving tangent gives the distance in feet that the bottom of the ladder should be placed away from the bottom edge of the pool in order to comply with the directions? So here's your swimming pool. It's 6 feet tall. Placing that ladder X feet away at an angle of 75 degrees. Using tangent. Tangent is opposite over adjacent. In relation to that 75 degree angle, that 6 feet is opposite that 75 degree angle, and X is adjacent to that 75 degree angle. So side opposite here is 6, the side that's adjacent is X. So you can say the tangent of 75 is equal to 6 over X, but we need to solve that equation for X because it says, which of the following expressions involving tangent gives the distance in feet that the bottom of the ladder should be placed away from the bottom edge of the pool? Well, that placement away from the edge of the pool, that is this side X. Distance away from the pool that the ladder is placed is side X. So we need to solve this for X. There are a couple ways you can do it. One way is you could just multiply both sides by X. You'd have X times the tangent of 75 is equal to 6, and then divide each side by the tangent of 75. You'd have X equals 6 over the tangent of 75, and that is letter F.